In integration testing, there can be two ways. Most of the time, in the initial era, people would combine all these units or modules or component together, one at another, all combined, and then test them as a whole. As the Big Bang approach is the way to test the modules as a whole, not individually, not in a combined way, one by one. But you are checking, combining it, and you are saying we have integrated and doing the Big Bang approach. But there will be a chaos, because now the errors once you are encountering, the correction will be very difficult, because the problem where it has come, the location, the isolation of the cause is not even complicated. It might be impossible sometime because everything is combined. So the best way is to use the incremental integration. What does it mean? We take one module, combine it with some subordinate module, and then check for the integration testing. When it is done, we simply add one more or few more and then check for the interfacing and other problems we mentioned. So program is constructed and tested in small increments, because now here the errors are easier to locate, easier to isolate and correct. So interfaces are tested completely when you have the incremental way of adding the modules and then checking, components and checking. So this is a systematic test approach that may be applied, and this should be applied. Integration testing. So integration is all about combining the component, the modules, and then testing. Let me tell you the bifurcation. First of all, we have integration. It can be divided into incremental integration testing and Big Bang integration testing. Big Bang is all about combining all the modules and testing all the modules at once. Incremental means adding one by one, incrementally, and then finally making all the modules combined one by one and testing in each step. So it can be bottom-up approach, we can apply top-down approach, and there is a sandwich approach also. So in integration testing, there are various different incremental integration strategies. So how do we do it? Let us start with top-down approach. As the name is suggesting, we'll start with the top. One by one we'll go to the direction which is vertically downwards. So an incremental approach for the construction of software architecture. That is, here we are more focused on the architecture, how these modules are there or the components, and then we combine them one by one. So modules are integrated or added by moving downward in this figure from top to down vertically through the control hierarchy. The top one is the main program, beginning with the main control module. We are calling it as a main program. So modules, these subordinate modules to the main control module are incorporated. So you can choose any method, depth first or breadth first. In the top down, you can either have depth first and breadth first. Depth is top to down, breadth is from left to right, subordinate. So depth first integration, it integrates all the components on a major control path of the program structure. So here comes the software architecture. So we'll start with the top and you will go directly down, that is vertically down. But which major path you will choose is arbitrary. That is, it depends totally on your application. These are application specific characteristics. I'll tell you an example here. See, here are certain blocks are there which are modules, which are components. So selecting the left hand path, the components, what we are going to add, we'll take the M1 first. I'm talking about the top down, then M1, then we are taking the depth first integration. So you can take any of these, but this depends, this is arbitrary. So M1 you start with, then you have to add M2 because this is top down and depth first integration. Then you have to go down. Either you can take M5 or M6. This is again application specific. But if M5 is dependent on M2 or M2 is dependent on M5, then you have to take M5. So start with M1, go to M2, then you will add next as M5. Finally, because there is only M8 is only there, so you will add M8. Right? Okay. Then after that, you have to add M6. In M1, you have 3 choices, M2, M3, M4. In M2, you have 2 choices, M5 or M6. Because this is depth first and top down, the chain will be M1, M2, M5, M8 first. Then we'll take the central one, that is the M1, M3, M7. Then we have to take the M4, that is M1 and M4. M1 is already taken, so then you have to take the left, middle and right in the depth first manner. How about the breadth first? So in this top down, we went from top to bottom. Depth first, we took the first one, vertically we came down. In breadth first, we have to take from left to right, that is horizontally. Horizontally means when you take M1, after you take M2, you will not take M5 or M6, you will take rather M3 and M4. So it incorporates all components directly subordinate at each level. So in the first case, what we saw, M1, M2, M5 and M8. But here, because this is breadth first, so we will not go to the depth, but rather will go to the breadth. Okay. At same level, subordinate modules we have to take. So we have to move across the structure horizontally. In depth first, we went vertically. How do you take it? Let us take the example from this figure only. So the component, because M1, after that what you are going to take? M2. And since M2, M3, M4, they are in the same breadth, so you have to take M2, M3 and M4. This is what you have to take. Then you have to go to the next level. This is again the next subordinate level. Then you have to take M5, M6 and M7. Finally, you have to add MA. So integration in these cases are performed in series of certain steps. Mainly the 5 steps we have. So how do we do it? The main control module, that is the main program, is used as a test. This is a driver, and stubs are substituted for all components directly subordinate to the main control module. Because in this case, maybe the main program may not have been made properly or the subordinates are not done. So you have to use the driver and stub. Depending on the integration approach, it can be depth or breadth first. Subordinate stubs are replaced one at a time with the actual components, and tests are conducted at each component. This is integrated whenever the components are integrated. On completion of each set of tests, another stub is replaced with the real component. So this regression testing may be conducted because maybe new errors might have come. So when we combine various module or component, some new errors may come. So regression testing can be done. So this top-down integration strategy, it verifies major control or decision points early in the test process. So this is very important, that most of the major decision points and control, these are being checked normally in top-down integration strategy. Because all control path we have checked if you apply depth first or breadth first. The integration, there is one more type, which is the bottom up. So we start with the lowermost and go vertically up. And you know, when we start with the small module or units, there may be possibility, and there is a strong possibility, that the upper module, which are calling it, may not have been made. So bottom up integration testing, it begins construction and testing with the atomic modules or the unit modules. Okay. So the functionality provided by the components subordinate to a given level is always available, and need for the stub will not be there, is eliminated. Because main module you are making and you have this module, so the subordinate module is our stubs, because you are already starting with the stubs. Means the bottom most, that means we don't need stubs in this case, bottom up integration. So what are the steps? See, the low level components, we combine them into clusters. We also call them as builds. That is going to perform a specific software sub-function. So these are the clusters we are making in this particular figure. I am demonstrating the cluster 1, cluster 2, cluster 3. Okay. So a driver, which is a control program, is written to coordinate the test case input and output. So this D1, D2, D3 are the drivers for 3 clusters we have defined. D1, D2, D3 is not made. Okay, so we have to write a driver here. So then the cluster is tested. That is the cluster 1. I'll just show you which cluster we made. So these 4, 1, 2, 3, 4, this is cluster 1. Then 1, 2, 3, 4, 5, this is cluster 2, which is below D2. Below D1 is cluster 1, below D2 is cluster 2, and then D3, below D3, the 2 blocks you see is cluster 3. So cluster 1 will be tested with D1, cluster 2 will be tested with D2, cluster 3 will be tested with D3. So each cluster, this is cluster 1, this is cluster 2, and this is cluster 3. So this cluster will be tested. And now the drivers which we made, D1, D2, D3, these are removed. And now the clusters are combined upward in a program structure. D1 will eliminate, D2 will eliminate, and will directly combine this cluster 1 and cluster 2 and cluster 3 with what? MA and MB. Each of the cluster is tested using a driver. As I said, you have to test a cluster using D1, D2, D3. D1, D2, D3 are the drivers. So the components in cluster 1 and 2 are subordinate to what? M sub A. D1, D2 was there. We already tested. Now they are subordinate of MA. So drivers D1, D2 will be removed, will eliminate it, and the clusters are eliminated. This interface, cluster 1 and cluster 2 are interfaced directly to MA. Similarly, D3 and D2 will be removed, and this cluster 2 will be directly fixed with MA, and this cluster 3 will MB, and finally MA, MB, because they are also, you have to do it using the possibly with a driver. And finally, everything will be combined with your final top one, MC. And need for separate test driver is less.